today's lesson is 7-8, which is solve inequalities. Okay? So, when you're on the warm-up, the IXL warm-up, you were finding solutions to the inequalities. So, what you were doing was you were taking the number that they gave you, and you were just taking that number and putting it into the equation, and then simplifying. And then if you got a true statement, then you know that that number that you substituted in is a solution. If you got a false statement, then you know that that statement, that number that you substituted in is not a solution. All right, so that being said, when you replace a variable in an inequality with a value that results in a true sentence, then you solve the inequality. So I want you to write that sentence down, and I want you to write down the information in this table. Okay? And I'll give you about 2 minutes. Okay. So now we're going to use substitution to determine if these whole numbers, 5, 6, 7, 8, and 9, are solutions to the inequality 2 plus x is greater than 9. So we're going to take the 5 and we're going to substitute that in for x. Does everybody see that? We're going to substitute the 6, the 7, the 8, and the 9. Okay? So when we substitute, now we simplify. So we've got 7 is greater than 9. Is that a true statement? No, that is false. Okay? What about 8 is greater than 9? False. Very good. How about 9 is greater than 9? No, that's false. It's equal. Very good. And then we've got 10 is greater than 9. Yes, that's true. And then that 9, 10, 11 is greater than 9. That is true. Is everybody clear with that? So what we did was we just substituted in, we simplified, and we got true statements and false statements. So with the false statements, these are not a solution. Those are not a solution. And the true statements are a solution. Is everybody clear with that? Okay? So, if you substitute and simplify and you get a true statement, the numbers that you substituted in, so 8 and 9, are solutions to the inequality 2 plus x is greater than 9. So for example 1, we want to find the solutions of an inequality. We want to know which of the following are solutions to that inequality. Okay, and we're testing 6, 7, 8, 9, and 10. So for this one, we're going to use substitution. We're going to use substitution. Okay, so that just means wherever there's a D, we're going to put in one of those numbers. So we've got a 6. So we've got 6 minus 6 is greater than or equal to 2. 6 minus 6 is equal to 0 is greater than or equal to 2. Is that true or false? That is false. So that tells me that 6 that we just substituted in is not a solution. So now, let's try 7. So we've got 7 minus 6 is greater than or equal to 2. 7 minus 6, of course, is 1. So 1 is greater than or equal to 2. True or false? False. So that means that 7 is not a solution. Is everybody following the pattern here? All right. So let's take a look at, what do we do now? 8, right? So we have 8 minus 6 is greater than or equal to 2. So 8 minus 6 is 2. So 2 is greater than or equal to 2. That is true. Very good. This is a true statement. So 8, I'm going to do it in blue, 8 is a solution. Okay? Let's do 9. So we've got 9 minus 6 is greater than or equal to 2. 9 minus 6 is 3. Is 3 greater than or equal to 2? Yes, very good. So what's a solution? No, 9. Remember, it's the number that you substitute in, okay? Now, let's do the last one. So now we've got 10. So 10 minus 6 is greater than or equal to 2. 10 minus 6 is 4. So 4 is greater than or equal to 2. True? That is true. So what is the solution? No. 10. Very good. Be careful. It is the number that you are substituting in. That's the number that is in question. Okay? Guys, that is one way to find solutions to an inequality. The next way I'm going to show you is using your inverse operations. You already know how to use your inverse operations, right? We're going to use our cover-up, right? Okay. So we want to know which of the following are solutions to this. All right. So we want to know which of the following are solutions to negative 28 plus c is greater than negative 72. We want to know which one of those is a solution. So we are going to use our cover-up. Now, the way you use your inverse operations, let's write this down. Use inverse operations. The way we solve an inequality, you guys, is the exact same way we solve an equation. So you're just going to, in your head, imagine that inequality says equals, okay? And then your steps are going to be the same. So we are going to cover up what we are solving for. So we're going to cover up the c. What do I want to get rid of? The negative 28. How do I make that negative 28 into a 0? Right. So we're going to add 28 on both sides. Remember, you want to keep the balance. Okay? So we're going to add 28 on both sides. Make sure you're writing this down. This is a number plus its opposite. That's equal to 0. So now we're left with c is greater than. So when we subtract here, this is going to give us a negative 44. We subtract the digits and take the sign of the bigger digits. So that's going to be a negative 44. So now, all we have to do is choose the values that fit in for C. So, is negative 43, let's write it down. Is negative 43 greater than negative 44? Yes, yes. Remember your negatives? That is a true statement. So, negative 43 is a solution. Now, let's put in the next one. Negative 44 is greater than negative 44. No, this is not a solution. Okay? How about negative 40? Oops. Change colors. Negative 45 is greater than negative 44. Is that true or false? That's false. This is not a solution. Is everybody clear? So the only solution to this is negative 43. All right, example 2 is finding solutions of an inequality. Now this one is a multiplication equation. What's the inverse of multiplication? Division. So, ladies and gentlemen, from now on, now that I showed you a substitution and I showed you an inverse operations, I'm going to continue with inverse operations. So we're going to use inverse operations with this one also, okay? So here, we want to cover up what we're solving for. And you guys, there's going to be a twist in this one, okay? So here, we'll cover up what we're solving for. And we want to get rid of what number? The negative 12. How do I get rid of the negative 12 if this says negative 12 times b? Right, because the inverse of multiplication is division. So we're going to divide by a negative 12 on both sides. Is everybody clear? So here we've got a number divided by itself. That's equal to 1. And 1 times b is b. And then we've got this greater than or equal to symbol right here. And then we need to do this division. Now, positive divided by a negative is a negative, right? And then, how many times does 12 go into 40? 3 times with how many left over? So that's 3 and 4/12. So down here, I'm going to write 3 and 1/3. I'm just going to simplify, okay? 3 and 1/3. Now, here's the plot twist, okay? If I choose, no, before I get, actually, I'm sorry, before I get to the plot twist, does everybody see how this is written backwards? All right. Now, I'm going to show you how to read this to make things easy for yourself, okay? You know I said we read from left to right, right? But variables in the back, right? So when you are reading a variable, when you are reading an inequality, you read the variable first. So we're reading this backwards. You see how my red stick is going? You're going to read it backwards. So this says, follow the stick, b is less than or equal to negative 3 and 1/3. So, according to this, I can choose b is less than or equal to negative 3 and 1/3. We said we're going to choose negative 4, right? So, if I put negative 4 into the original inequality, we have 40 is greater than or equal to negative 12 times negative 4. So this says 40 is greater than or equal to, what's negative times a negative? And this is going to be a positive 48. Is that true? No, that is not true. How do I make 40 is greater than or equal to negative 48? How do I make that a true statement? You just have to flip the inequality symbol. So when you are multiplying or dividing, make sure you write this down, by a negative number, you must flip the inequality symbol. Make sure you write that down. This is extremely important. That's the plot twist I was telling you about. Okay? So, this is not the correct inequality. We're going to write instead b is, I'm going to flip that inequality, and then negative 3 and 1/3. So now we're going to read this. Says b is greater than or equal to negative 3 and 1/3. Is everybody with me? So which one of these is greater than negative 3 and 1/3? Negative 3 is greater. Yeah, 4, because that's a positive, and 5 is a positive, right? So we can pick those, right? So let's check it out. Let's put those into the inequality. As we know, we already put in negative 4, right? We know that's not a solution. So let's put in the others. So we've got 40 is greater than or equal to negative 12 times negative 3. That's 40 is greater than or equal to 36. Is that true? Yes. Does everybody see how flipping that inequality makes it a true statement? Yes. All right. Then we've got, let's do another one. We've got 40 is greater than or equal to negative 12 times 4. That's 40 is greater than or equal to negative 48. That is true. Very good. So now we've got 40 is greater than or equal to negative 12 times 5. So that's 40 is greater than or equal to negative 60. Is that true? Yes. Is everybody clear? So this, this is your answer, okay? And remember, when you are reading an inequality, you're going to read it with the variable coming first, okay? So you're going to read this, b is greater than negative 3 1/3. Is everybody clear? All right. And then this rule down here is extremely important. This is when you are multiplying or dividing, okay? When you multiply or divide by a negative number, you must flip the inequality symbol. So here we have a negative 3k is less than 15. So what do I need to get rid of? The negative 3. So what am I going to do to get rid of the 3? Negative 3. Divide. We're going to divide by negative 3 on both sides. Is everybody clear? So here, negative 3 divided by negative 3, that's 1. And 1 times k is k. So k is less than negative 5. Is that correct? No. What am I supposed to do? What am I supposed to do with this inequality symbol? You must flip the inequality symbol. So this is not correct. We want to flip it. I'm gonna erase. I'm gonna rewrite it. Okay. So I'm gonna write. Don't forget to flip the inequality. Quality. So our actual answer is k is greater than negative 5. So out of these values up here, what are my solutions? K is greater than negative 5. Negative 6? No. Negative 5? No. 5? Yes. 6? Yes. Is everybody clear? All right, so now we want to find the solutions of inequalities in the word problem, okay? It says, at the end of his vacation, Mr. Ote has $55 left to spend at a souvenir shop. He would like to buy some picture frames that cost $13 each to display some of his vacation photos. The inequality 13f is less than or equal to 55 represents the number of frames f he can buy. What is the greatest number of frames that he can buy? So the inequality that we are working with, they gave it to us, right? Is 13f is less than or equal to 55, where f represents the number of frames. Is everybody clear? Okay. So f equals the number of frames. So now all we have to do is solve. 13f is less than or equal to 55. Using my inverse operations, how do I get that f by itself? Right. We are going to divide by 13 on both sides. Okay? So those 13s on the left cancel to 1, and 1 times f is f. Do I need to flip this inequality symbol? No, because that's a positive, right? Good. So then we use our calculator. We've got 55. 55 divided by 13 And that's going to give me this big long number. Okay? So 4.2307, blah, 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 right? So 4 point, what did I say? 2307. 2307, blah, blah, blah. Now, on this one, remember, you can't buy part of a frame, right? This over here is part of a frame, right? So that means that my final answer is F is less than or equal to 4 frames. Is everybody clear? All right. All right, Joel has $115 to buy soccer balls at the cost that cost $9 each for the players on his team. The inequality 9x is less than or equal to 15 represents the number of soccer balls S that he could buy. If there are 12 players on the team, how many could receive a new soccer ball? Okay, so they're giving us the inequality, right? That's 9x is less than or equal to 115. You with me? Now, to get the x by itself, we're going to divide by 9 on both sides. So here, those 9's cancel, and x is less than or equal to, and we've got 115 divided by 9, 12.7. 7 repeating, right? So this is going to be 12.7 repeating. So he can only buy 12 soccer balls. So x is less than or equal to 12 soccer balls. So everybody gets 1. Everybody gets 1.